Okay, so we're going to kind of turn our attention to graphing things now. I just kind of want to make sure that you know a couple things about graphing. First off, it's not necessarily you're always going to be graphing within something called the first quadrant. We talk about quadrants in mathematics. Doesn't matter what grade we're in or what type of math that you end up going into. The quadrants of mathematics always contain, or there's always four quadrants of mathematics. There's quadrant 1. There's quadrant 2, there's quadrant 3, and there's quadrant 4. Let's see if I can do that a little better. There. Quadrant 1 contains positive x values and positive y values. Positive 2 contains negative x values and positive y values. Quadrant 3 contains negative x values, negative y values, and then quadrant 4 contains positive x values, but then negative y values. And these are the four quadrants that we use to graph relations out. They could be functions, they could not be functions, but it's just graphing anything that has two variables. And we can call these variables pretty much anything. I can call them distance and time. I can call them time and money. I can call them x and y, like I have here. So I wouldn't get your hopes up, let's say, of only graphing in quadrant 1. A lot of graphs will be in quadrant 1 because we're dealing with positive x and positive y values. And this just kind of makes sense when we deal with a lot of applied type questions. Think about like number of items sold and the cost that you get, like profit. Those are both going to be positive values. You can't sell negative objects and you can't get negative money, or let's just assume that you're not. Or something like with time. You will only have positive time. You will never have negative time. So a lot of the times you're only going to be looking at quadrant 1. But these quadrants here, they kind of encapsulate everything to do with graphing these linear functions. So something like this. Y is equal to 2x plus 1. And it's just a straight up graph question. You will have the knowledge of graphing this straight from the equation without needing a table in our next unit. That's the whole goal of our next unit, is to basically make these types of equations and be able to graph them, or to be able to get them from a graph immediately without having to rely on a table. But tables are still useful. Don't get me wrong, tables are still useful. But this is what I would have for some advice for you. First, is there context for the question? In this question, there's absolutely no context. It's just y and x. It doesn't mean anything, and it's just a relation between y and x, and it happens to be a function here. If there isn't a context, are we looking at discrete, or are we looking at continuous? Now, 9 times out of 10, we're going to be looking at continuous functions unless there is a context. If there isn't a context, you're basically guaranteed to get a continuous function no matter what, unless there's some other restrictions going on, which you really don't have to focus on too much in grade 10. So we're going to be focusing a lot on this continuous. 3, where is your graph? These are kind of the questions that you should ask yourself. So when you're trying to graph these ones out and there isn't a context, we're going to have a continuous graph, you should be able to get a couple values of x, and I would always choose different values of x. I'd pick at least 3. One being negative, one being maybe 0 or close to 0, and then one being positive. I just made up this table due to this graph. I just made it up. And I got the associated y values from it. Now, you might be thinking that, hey, this really looks like a discrete set of data. It is not a discrete set of data. I haven't said that x has to be integer values. I haven't said that this is going to be a modeling after a certain applied context. This is just x and y, and they can be anything I want. But to get the shape of the graph, I'm going to have a negative value, 0 is a good idea, and then a positive value. So when I'm making my graph, I'm going to kind of give myself a little bit of an axis here. I'm going to go down here. I should be using a ruler. I don't really have an electronic ruler to use, so you'll just kind of have to bear with me as I draw it. It's not the straightest, but I think we're okay. I'm going to put some arrowheads on my axis. x. I'm going to label it out. This is x and this is y. And let's take a look at my values. I have -2, 0, and 2. I have enough space on my x-axis that I can confidently put -2 here, +2 there. I have to go all the way up to +5 and down to -3. I can confidently put 1, 2, 3, 4, 5, and 1, 2, 3 on my graph. I could choose different scales for both of these. I don't have to put one square means one tick mark and equals one value. I could go up by 2s if I wanted to and have one box equal 2. And it can be different for x and y, but I have to maintain a consistent scale for x's, a consistent scale for y's. Just basically proper graphing techniques. Let's put our ordered pairs down. Our first ordered pair is at -2, -3. So let's put that down on our graph. We got -2 and then -3. Our second one is at 0 and 1. And then our third one is at 2 and 5. Now, I've just said that this is going to be continuous data. This is not modeling anything. This looks like this could be discrete, but I've made up these values based upon this equation. I can put anything I want in for x. I can put in something like, if I really wanted to, I could put in negative 0.776 and keep on going for decimals. I'm going to get a value for y, and it's going to appear on my graph. I'm guaranteed that. So what this is a linear function. I can see that my y values are going up by 2 apiece. Maybe I can just kind of look at this 2 over here as a rate of change. I can take a look at these 4 apiece, my mistake, plus 4 apiece. I can take a look at these are going up by +2 apiece. And see the rate of change of my dependent variable divided by the rate of change of my independent variable equals 2. And I can see that when my independent variable is 0, my dependent variable is 1. Hey, that's where that came from as well. So just kind of an FYI for later on. Now, if I'm going to make my graph, I'm going to connect these with, hopefully, a straight line. Not too straight for me, but hopefully a little straighter for you. And I'm going to put arrowheads on the back of them. So when we're graphing here, what I would advise you to do is from a given equation, like this. I would say, ask yourself, do you have context with the question? If not, you're probably going to have a continuous function, which means that you're going to have to use a line to connect your dots. Where is your graph? I would get a couple of different x coordinates, one being negative, one being 0 or near 0, and one being positive, and get those associated y's, and then you can connect your dots afterwards. Make sure that you can take into account what your scale is going to be. Make sure you can take into account how to plot these points out and kind of what quadrants you're going to use. I had to use all 4 quadrants here. So I needed to make my graph to use all 4 quadrants. That might not necessarily be the case with all the graphs that you have. So you don't always necessarily have to put an x and y axis, but more times than none, it's a nice practice to do that. And definitely into our next unit, we are going to be using all 4 quadrants in our graphing.